Welcome everyone. In this video lecture, we will solve a numerical problem on Mosfet circuit DC from Microelectronics circuits book. So the question is, analyze the circuit shown below. So the circuit is given to determine the voltage at all nodes and the currents through all branches. So we have to find the voltage across each node. So we have to find the voltage across the gate. Okay. We have to find the voltage across the DEN. Okay, we have to find voltage across the source in, okay, and the current across the each, and the current through the all branches. So first we have to find the id in this one. So we have to find this id current. Okay, and this current will be 0 because the gate is very high impedance, so generally we have to take it 0. So no need to find out this one. And this is the drain in, and this one is a source in. So id, and we have to find this current. Some current will be there, say I am saying simple I current. Okay, so this current will be same as this one I, and this one is same as that of id in the source terminal. So that we have to find id as well as the value of I. So all these things we have to find. So it is a very simple concept that to find the value of Vg. Here there will be no current. So if we consider only this portion, okay. So I am just making for the calculation of Vg. This current is 0, so no need to worry for this one. VDD is 10 volt, and this one is RG1, and this one is RG2, and this current is 0, so no need to. And this current is same as that of I. Okay, and this one will be our Vg. Okay, so it is somehow looks like a 10 volt battery. Okay, so I am just making a 10 volt battery, and there will be a RG1 resistance and RG2 resistance, and this one is RG2, and we have to find this value. That is our Vg. This value is Vg, so this one we have to say Vg. So this Vg can be easily find by using voltage divider concept. That is our VDD, that is our 10 volt into Rg2 by Rg1 plus Rg2. So this can be our 10 volt, so 10 and 10 mega, so 10 mega by 10 plus 10, so mega will be cancelled, so it should be 10 into 10 by 20, so it should be 2, it should be 5. So this should be our 5 volt. So Vg will be 5 volt. Very simple. Vg calculation is now very simple. You have already find this Vg by making this, by choosing this portion. Okay. Now we have to move forward for the drain current. Now we are going for the drain current calculation. So I am writing drain current calculation. Okay. So now before drain current calculation, what we have to do? The Vg value is 5 volt. Okay. So what we are doing? We are assuming that get to source voltage VGS is greater than VT, so, and the transistor is in the on state. So the device is in the either saturation or linear. Okay, there are two possibility for this condition. Means either it should be saturation or linear depending upon the condition. So we are assuming that for EG calculation, we are assuming that this the circuit is in the saturation region. So one can write the drain current equation will be 1 by 2 K N dash W by L VGS minus VT whole square. Why we are writing? Because it is simple, where there is no involvement of drain to source. So we are just, if it will not follow this one by assuming, by calculating all ID RD value, sorry, VD value and Vs value. So it may be in linear or situation, it will be decided at the end, but we are starting with the that the circuit is operating in the saturation region. So in this case, the ID value is this equation, very well known equation. So this ID can be written as 1 by 2 K and dash is 1 milliampere. So I am just writing K and dash WL 1 milliampere. So I am writing 1 only, milli and ID in milliampere range. So make it milli. So it should be Vg minus Vs minus Vt whole square. So once again we can write this as a half. Get voltage is now known to us, that is our phi, minus Vs. Vs is not known to us, this voltage. Okay. So for this voltage, what we are saying, this Vs. So this Vs is nothing but simply Id times Rs. Id times of Rs. Simply this one is our Vs and this one is a ground potential. And we know that the drain current will be like this, Rs. So ID value can be written as Vs minus 0 by Rs. So voltage across the source in is simply ID times of Rs. So this one is an important point. I am highlighting this one. Okay. So this will be simply ID times of Rs. So one can easily write, instead of Vs we have to write ID Rs minus 1 whole square, or this can be our 5 minus 1 4 minus ID Rs. Okay, Rs is in kilo ohm and ID is in the milli ohm. ID in the milliampere, so milli and this will be cancelled out, and ID we are assuming in the milliampere, so no need to write milli and kilo thing. So we have to take care about this thing. So now, okay, and one more square term will be there. This one is the ID value. So ID value will be 1 by 2 this. Okay, so one more line we have to do, like a minus b whole square. So we can write 4 minus, okay, one more line I want to write, because we know this one is 4, RS which value is 6, so directly we can write 6 ID whole square. Okay, RS is 6 kilo ohm. So 6, better to write 6. ID in the milliampere. So milli and this kilo will be cancelled. So simply we have to write 6. So it should be our 1 by 2. This should be 16 plus 36 ID square minus 4 into 2 8. 8 into 6 40. 48 ID. A minus B whole square, simple formula we have used. So after that, again we will write each and every step. So it should be our, after solving 8, then 18 id square minus 24 id. So I once again I writing, if we put this in the right hand side, so after simplification we can write it 18 id square minus 25 id plus 8 equals to 0. So this one is a drain equation in quadratic form. So we can easily find the value of ID. So what we have to do? Once again, we can factorize this one. So this can be written as 9 ID minus 16 ID plus 8. Because 18 into 8 around 144, 144, 144, so 16 into 9. Okay, is also 144. So like that we can do simple factorization, and you can use the quadratic equation concept. So now next, so one can write this as a, if we take 9 id common, so it should be twice id minus 1, then take minus 8 common, then twice id minus 1 equals to 0. So there will be two root. So one more line we have to write 9 id minus 8 and twice id minus 1 equals to 0. Okay. So next what we will do, id value will be, one value will be 1 by 2 from this one, id value will be 1 by 2, and from this one id value will be 8 by 9 in milliampere. Okay, so this one will be 0.5 milliampere. We have assumed this one is milliampere, and another one is our 8 by 9, so it is nearly 0.89 milliampere. So there are two value, so I am highlighting these two value. Okay, am I highlighting with the green one? Okay, so now we have to decide which one is the correct id, 0.89 or 0.5. Okay, so for this purpose what we can do, our get to source voltage will be greater than 0 for transistor is in the on state. So what we can write here, VGS should be greater than VT. Okay, so what, or greater than equals to VT. So what we can do, so get voltage is given. So now we have to find the source voltage. Okay, Vs equals to simply our 6 times of id, rs, that is our id is id into rs is 6, so 6 kilo, so and milli will be there, so 6 id we can write simply 6 id. So when it is id value is, when we are taking 0.89, okay, 8 by 9, so 6 into 8, 0.89, it will come nearly 5.34 volt. So now vg is 5, but vgs, vg is 5 minus 5.34, some negative value is coming minus 0.4 is greater than 1 volt, so it is wrong. So we can say this value will not be the correct one, id. Okay, we have to calculate, because for the transistor you operating, vgs should be greater than vt, but here it is coming negative. VGS value is coming negative. VG is 5 volt and S is 5.3 volt by keeping ID this one. When ID, if we take ID value as 1 by 2 or 0.5 milliampere, the VGS value, okay, VGS is 5 minus VS. VS means ID times of RS. Okay, ID RS. So 5 minus half into RS is 6. So 5 minus 3, it should be 2 volt. So VGS is here greater than VT, so this one is the correct one. Okay, so that's why this ID will be the correct one for the circuit. So the ID value in the circuit will be 0.5, so it should be 0.5 milliampere. Okay, this one is 0.5, 0.5 milliampere. So one can easily say ID value, the correct ID value will be 0.5 milliampere, and the value of Vs is 6 times of ID, IDRS. This one is simply IDRS. So ID is our 1 by 2, 1 by 2 or 0.5 milli, so 10 to the minus 3, and RS is our 6. You see, RS is 6 kilo ohm. Okay, so better to write 6 kilo ohm 10 to the power 3. So this should be cancelled out to 3. So 3 volt. So Vs is 3 volt. So ID is known to us, Vs is known to us. Now we have to find the value of Vd. So there is a voltage, that is our Vd. Okay, so that we have to find. So what we are doing, there is a resistance VDD, RD is there, we have to find VD, and this one is ID current is there. So VD value will be simply our VDD minus ID into RD, simple. Okay, so this voltage we can easily find a VD equal to VDD minus IDRD. So VDD is 10 volt. Okay, make it 10 volt minus ID 0.5, so 1 by 2 milli. So and RD value is giving, RD is also same as RS 6 kilo ohm. Okay, so it should be cancel out. So 10 minus 3 volt, so simply this should be 7 volt. So the VD value will be 7 volt. So once again I am highlighting, this Vs will be this one and Vd will be 7 volt. Okay, so now we have find Vd, Vs, Id. Okay, Vd, Vg also, Id and I. Now we have to find this I current in this loop. Okay, so the for the I current calculation, okay, we can directly go from this side. Okay, uh, here I am writing. For the I current, what we can do, the okay, I'm selecting some different color. This I will be okay. I is also required. So this I will be VDD by RG1 plus RG2. Same kind will flow. So this should be 10 by 20 mega, means 10 to power 6 is there. So 1 by 2. 1 by 2. Okay. So we can write it 0.5 micro. If it will go up, so I value will be 0.5 micro ampere. So all unknowns are there. 0.5 microampere is this one, 0.5 milliampere is this one. So we have already find the all value. So here I am writing Vg value is 5 volt. Okay, we have already find the Vd value we have find the Vd value will be around 7 volt. Vd will be 7 volt, so it should be our 7 volt. Vs value will be Id into Rs, so it should be 3 volt, 10 volt, so 7 volt drop here, so 3 volt. Vs is 3 volt, so you just see Vs is 3 volt. Okay, now Id is 0.5 milliampere, and this I, the current in this Rg1 Rg2 resistor will be very small, that is our 0.5 micro ampere. Okay, so this is all about this simple question. The thing is that we have to very careful about the process, and we have to find all the values step by step. So this is all about this question. So thank you for watching this video. I'm just also highlighting the this all term. Okay, clear. So this is all about this question. So thank you for watching this video.